Welcome to a new lesson. Before we talk about the new lesson, let's review a couple of important terms. Inequalities. There are four major inequalities that we need to discuss. The less than, the greater than, the less than or equal to, the greater than or equal to. There is a very simple way to understand what the sign of inequality means. The way I remember it is always the small and the large. The large points at the small, or you could draw the little teeth that the small is trying to eat the large. And what are we talking about, the small and the large? We're simply talking about values. To write an inequality that corresponds to a statement, replace the words that represent the inequality with the corresponding sign. G is greater than or equal to 5. This means that G is a greater value and is equal to 5. Therefore, G is a greater value. That means it points at 5 because 5 is smaller. And we could draw this inequality on the number line. Since it is equal to as well, it starts at 5. And it includes all the values that are greater than 5. And all the values that are greater than 5 are on the right-hand side of 5. So not only do we draw the shaded circle around 5, but we also extend the line all the way to the right-hand side and we also indicate an arrow showing that it goes on forever, or the values can be greater than 9, 10, and so on. Let's continue on with inequalities. What if x is greater than -3, however it is less than or equal to 2? How would we write this inequality on a number line? Notice the way we write it. The -3 is always located on the left-hand side, while the 2 is located on the right-hand side. And the reason for it is because we have to indicate the progression of the order of magnitudes. Meaning is that the smallest one should be on the left side and the greatest one should be on the right-hand side, because we write from left to right. Now read the question. X is greater than. That means x is a larger value that points at a smaller value. What about the 2? The 2 is greater than, therefore the 2 is pointing at x. But it's also possible for it to be equal to x. That's why we write the little negative sign below, or a dash below the arrow pointing at x. How do we write this on the number line? Since there is no line underneath the arrow pointing -3 from x, we do not shade that region of -3. And since x can be from -3 to 2, we extend that line up to 2. Now because that line is present, that means x can be 2, we shade the area for 2. And since we don't have any values for x that are greater than 2, we don't draw any regions beyond the 2. In a different way, you could think of that x is trapped between the values of -3 and values of 2. It includes 2, that's why we shade it, and we don't include in the -3 in shading because it's greater than -3. This inequality is very important to understand the next lesson, which will deal with domain and range. So let's talk about, before we talk about domain and range, we're going to talk about how graphs represent a function. So let's look at this example. Which of these graphs represent a function? Justify the answer. Let's refresh our definition of what a function is. A function is a relation where each domain value is related to exactly one range value. Or in other words, each input is related to exactly one output. It's difficult to use this definition in graphs because we would have to draw or actually just write order pairs for each point. That means each point on the graph, we would have to find out what all these points are and relate them to see if they're a function. There is a quicker and a faster way to do this. It's called a vertical line test. Vertical line test. A vertical line test works on the principles that we draw a vertical line through each and every point. Like so. So we do both graphs at the same time. And if each of these lines has only one point that we drew, then it's a function. But if it has anything more than one point, then it's not a function. So let's take a look at part B. First, there are 1, 2, 3, 4, 5, 6 vertical lines, and each one of them touches a point. Only one. Therefore, it's a function. However, in part A, this line right here touches 2 points, while this vertical line touches 3. It breaks the rules. It can only touch one. Therefore, it's not a function. This graph is not a function. Let's take a look at a different example. This is where we're going to use the inequalities to find the domain and range of each of the graph. Recall the domain deals with the x values. Why the x values? Because that is the horizontal axis, while the y values are represented by the range. It is a good practice to start drawing what specific parentheses for set notation for this answer. It is often customary to understand the graph and looking at it to see where does it begin and where does it end. So it begins right here and it keeps going down, and it doesn't have a dot on the left hand side, therefore it must continue on forever and ever, forever up and forever to the left. So how do we find the domain of this function? Now suppose we draw a straight vertical line from the starting point to the horizontal line, or the x-axis. This x-axis now becomes a number line. Now we have a shaded area because of the shaded area on the point on this curve. Now where does it go? We know that it starts at 3, so this is right now at 3. But we could do all the other points from all the graph, from the curve, by vertical lines straight down. And we notice that if we put all these points together, it would draw a straight line forever and ever going to the left. Because of this fact, we have an inequality. We know that our x values are going to be less than and equal to 3. Why? Because 3 is the smallest value, and the graph continues all the way to the left. For the range, we're going to do the same thing, except now we're going to draw a vertical line. We're going to use the vertical line. Let's use the horizontal line with the first starting point, at least here. So this is our shaded area. However, it's not necessarily the same thing as with the x, because if we continue on and doing the same kind of method as before, but now drawing just horizontal lines, we'll notice that the line would continue on all the way to the bottom and stop right there. What we missed, however, is the left hand corner. See this goes forever to the left. So if you continue on drawing horizontal lines from that curve to the x-axis, we'll continue on drawing forever and ever up. So in this case, it's harder to see, but it's still possible to see that we are really starting at this y value. And that y value, if you look at the divisions is 1, 2, 3, 4. This division is 1, and we are starting at -1 y. And we're going all the way up, and forever and ever. And our smallest value for y is -1. So now -y will be less than and equal to, because it touches -y, then y. We could write the same thing as y is greater than and equal to -1. So in doing domain and range, it's very important that you draw or visualize a number line. Then the domain will be a horizontal number line, and the range will be the vertical number line. Now take a look at question B and find a domain. Again, we're looking for the x or the horizontal axis. Notice that x on the horizontal axis is trapped between -2 and 2. What do you mean trapped by that? If we extend the vertical lines from the points and make it little points on the x-axis, we notice that we'll get a little line connecting from 2 to -2, starting at 2 and finishing at -2. That means x is trapped and touching, so it means its x is less than and equal to 2. And since it's also touching -2, and to the right of -2, it is greater than and equal to -2. As for the range, we're looking at the y values. The highest point for the y and the lowest point in the y is 2 and 0. That means the y is trapped or contained between 0 and -2, and it also touches 2. That means y is going to be less than and equal to 2. But however, it's always going to be greater than and equal to 2 because it does touch the 0, and it's maintained with it. And another way to look at it is that what if you draw horizontal lines from each point on the curve and do dots on this line? You'll get a number line that stretches from 0 to 2. Let's take a look at a different example. Determine the domain and range of the graph for each function. Now, with this question, try to solve it yourself. The first hint you'll get is that the little dot means that it touches that point, and since there's no dot on the left-hand side, that means it's an arrow. That means the line goes forever left and down. So what's the domain of this function? Again, we're looking for the horizontal axis. So draw vertical lines, and x starts here at 5. This is 5, and goes forever to the left. And the reason why it goes forever to the left is because the graph goes forever down and left. So since it goes forever to the left, x has to be equal to, because it touches the 5, and less than because it's all the values that are less than 5. So that's why this is the domain. in the range, we're looking for the y, specifically the y-axis. I'm just going to erase everything else. And notice that the highest point for the y is the 2. So 2. And since the graph goes forever down, the number line that represents this starts at 2 and goes forever down. So that means y is going to be less than and equal to 2 because it does touch 2 and all the y values on the graph are below 2. Now let's take a look at B. Let's find a domain for this graph, and let's find the range for this graph. So the range for this, the domain for this graph. Again, look at the x values. The highest x value is a 5, and the lowest x value is a -3. And since it's touching both -3 and +2, x is trapped or is contained between -2 and 5. So -2 and 5. That means x is less than and equal to x is greater than or equal to -2 and less than and equal to 5. Now what about for the range? Now draw horizontal lines to line up, and we have a 7 as maximum y value and a 3 as a minimum y value. That means y is between 3 and 7, and since it's touching these values, it is less than and equal to 7 and greater than and equal to 3. Let's take a look at a different example. Determine the domain and range of the graph of this situation. This graph shows the number of fishing boats N anchored in an inlet in Queen Charlotte Island as a function of time t. Identify the dependent variable and an independent variable. Justify the choice. Why the points on the graph not connected, explain. Determine the domain and range of the graph. So let's first identify the dependent variable and the independent variable. In a graph, the independent variable is always written as the horizontal axis. That means that it is time. Therefore, the dependent variable, in this case, is the number of boats. Number of boats. Also, it makes sense because at a certain time when you measure, there is a number of boats. It's dependent on the time. For example, at midnight, there should be no boats. So why are the points on the graph not connected? That is because the time that we measured is discrete. That means we've measured the number of boats, or we counted the number of boats at a specific time. For example, we count the boats at 9, at 10, at 11, at 12, at 1 p.m. or 1300, at 1400, 1500, 1600. So every hour we counted the number of boats. If the graph was connected, that means we had to measure the boats at maybe even at every second or every split second. This caused the graph to be continuous. But because we measured every hour, the graph had to be not connected. Also, it is possible if you have a point somewhere on the graph, such as, let's say, we draw it again like this. What does this identify? It's not touching with 24, but it's not really 25, which is this point, that means we can have 25 or 24.5 of a boat. But we know that it's not possible. We cannot have fractions in a boat. Well, you can either have one boat, two boats, 24 boats, but not half of a boat. What? A shark bit it? Took half of it off? We can't have half of a boat. And that's why this graph cannot be connected. And the last part, C. Determine the domain and range of the graph. See, since this graph is non-continuous, the points are not connected, we have to state the domain and range values in a list format. So this means, so this is domain, and we have to list them separately. Remember, domain is the horizontal axis. So we have 9 o'clock, 9. We have 10 o'clock, 11, 12, even 13, 14, 15, 1600 hours. 13, 14, 15, and 1600 hours. While the range is, if you look, just erase this, it is the lowest point first, and that tells you that it's about 6 boats, then 8 boats, and 10 boats, and it's about 11 boats, this is 15 boats, and last but not least it's 25 boats, and 25 boats. And that's the domain and range. We would use inequalities if the graph was connected, but since the graph is not connected, we'll only have to use list for dots on the graph. Let's take a look at our last question. Determine domain values and range values for the graph of a function. Here's the graph of a function f of x is equal to negative 3x plus 7. Determine the range values when the domain value is negative 2, and determine the domain value when the range value is 4. What they're really asking is that find the y value when x is equal to negative 2. And for part B, they're asking what is the x value, question mark, when the y value is 4. We're going to read this from the graph. So when x is negative 2, when does this occur on the graph? So look at the horizontal axis like here. Where is x is equal to negative 2? Well, it's right here. So go up to the graph until you meet it. And it happens right here. What is this represented as a y value? What is that y value right there? Well, we know that this is 14, and the y is somewhere between 14 and 12, halfway, so that's 11. So y is 11. What about the domain value when the range value is 4? So let's erase everything else. And now we're looking for the vertical axis. So when is it 4 on the y? It's right here. So we progress to the line, and we're looking at the coordinate point on the line that's like this. Oh, that's circled. So we need to find out what is this x value. So go down to the x-axis and find out that this is represented by x is equal to 1. So domain value when the range value is 4, that means y is 4, x is equal to 1. And that is all for this lesson.